it's a theory that was born roughly around 1996. It's based on a work that is co-authored by Professor Henrik Swanmark and Egil Friis Christensen, the late professor. He just passed away a month ago from Denmark. And what they were able to demonstrate in that era was very interesting and it got me really excited myself. It was about the idea that, they were able to show the interesting correlation between cosmic ray changes versus cloud cover changes. So let me put that all in context. The cosmic ray is measured in something what we call the neutron flux. Okay? And the cosmic ray intensity is inversely related to solar activity in the sense that as the solar wind is stronger, so when the activity is strong, the solar wind actually does get intensified and there's more magnetic flux expulsion. So this Earth is much more shielded against incoming cosmic ray. Cosmic ray, by the way, is nothing but very, very fast charged particle, mainly proton, really. There are a little bit of neutron because they are moved. There are a bit of other stuff, right? Alpha particles, which is the nuclei of the helium. But they are very small in terms of coming from space, but from the sun it's a lot more. And basically this solar wind is able to shield out when it's strong, so there's less cosmic ray coming in, so therefore your thing is no cosmic ray on the ground, right, when you measure. And the sun, solar wind is weak, then more cosmic ray coming in, so the cosmic ray peak at the solar minima, activity minima, just the opposite, right, when it's strong. And what they were able to show is that when you have peak cosmic ray incoming, and they were able to show that more cloud form. So when it's maxima, less cloud form. So that sort of fit into the paradigm, the ideas that maybe that this cosmic ray, because they are very fast incoming, they are not stopped by the Earth's magnetic field because we're not as strong compared to the solar wind. So they penetrate through and they were able to cause ionization in the air, in the atmosphere, basically in the ground, in the office here, your office, your room. They are able to penetrate. What they do is that they ionize the air. They were able to strip electron of something, of the molecules, of the atom if it's around. Strip that off, but because the air is so dense, this thing quickly get recombined. It's actually of the order of only milliseconds to 10,000 of a second. So that's why we don't see them. That's why the air is always neutral, because it quickly got back, because too much air around, right? So that makes hypothetical sense, because that one was kind of proposed already long ago by a person named Edward Ney from University of Minnesota in the 1950s, where they flew a lot of balloon, where they're trying to measure the property of cosmic ray. And they realized, in fact, I traced it back. The idea is not starting from Henrik Swanmark and Friis Christensen. You can trace all the way back to even Christian Birkeland and a bunch of those. There's a guy, I forgot the exact name, but he's from Denmark, by the way, coincidentally, was formulating the ideas in the 1900s. Christian Birkeland trip to the North Pole and all those regions is about 1903, I believe, the expedition. And they spent a year actually out there. They were doing all kinds of magneto measurement. At that time, they know something to measure that. And they were really proposing already. No, the guy's name is Paulson. I remember now. Paulson is spelled P-A-U-S-O-N, Paulson. This Danish scientist who already proposed that early on, that maybe it had to do with cosmic ray. That was very attractive. I like it very much. But the problem is that was shown for the data of the cloud from 83, 85 or so, because 83 they didn't have much data, 85 until about 1993 and 92. So you imagine, it's almost half a cycle, almost not a full cycle even. Very attractive. I was very excited. By 1997, I was a full supporter of this theory, this idea, this notion. In the sense, I also have to be fair, I wouldn't call it a theory anymore because it's kind of untestable as of today because of politicization of science. That Henrik Swanmark, God bless him, worked very hard. They continue this idea that maybe it's true, that this whole idea. But let me tell you my reservation on this topic. People may not like me after this, but so be it. I'm a scientist, so I speak my mind. Two problems. One of the biggest problem is that the cloud data that they use has continued since then. Let's say the project is called ISCIP, International Satellite Cloud Project, okay, run by Bill Russell from NASA GIS. It measured at the first point, it's 83, and then it continued until 2003 or so. Okay, so you can imagine if you show the data from 92 or 93, that's where Schweinmark stopped. He produced a paper in 96, so you have a lot more data. You show that, how does it compare? When you show that, all the relationship break down, there's no more correlation. So again, this is what it means by correlation, doesn't mean causation, and one has to be careful. As a scientist, I'm highly critical. So in 2000, I actually make some effort to contact them and give comments to Schweinmark, and Fritz Christensen is less involved because ever since then, Schweinmark ran on his own. Between he becoming a professor, he hired his own postdoc. We were trying to communicate with them, showing them that one of the papers they published in 1998 in Physical Review Letter is probably not correct. What I mainly claim is that maybe they misidentified the inverse relation between the cosmic ray versus the irradiance effect. Because it's very well known. There's an inverse relation between solar activity and the cosmic ray. It could easily be, okay, that you have more or less cloud related to how much the sun irradiance affecting the water vapor output. That's simple as that. And they refused to listen to us. I tried to publish a comment in Physical Review Letter, but it was not published, but I have the paper. Anybody wants to read is fine. During that time, I become totally convinced the effect could not work because I realized that I talked to the person who generated the satellite ISCIP project. Because Heinrich Schwarzmark since then have adjusted the data to change it a little bit. And by all reason, if it's true, and if the satellite data people agree with that kind of adjustment, then I would agree with Schweinmark. But unfortunately, this friend of mine who worked with me from Colorado State, Fort Collins, his name is Garrett Campbell, he did not agree with that. That's why he joined my paper, but they don't want to listen. That's a bit sad in that sense. That's just the empirical basis. What I mean is that the empirical basis for proposing this idea is not strong. That's one point. Second point is, in some sense, when you come in from another field, he's from space physics, and then there's another character by the name of Professor Nershavith, has also been thinking deep about this issue. But they're from astronomy and space physics. They really have studied the climate, that's true, but they really didn't want to think deeper. The problem, as I just say, is that the cloud field, what they are proposing is that this thing is controlled. The cloud formation is controlled by the microphysics. Remember now we're talking about nano-sized particle attaching to water droplets, so they build it up, ultimately make into size of a cloud. Cloud is on the order of, you can look out in your sky, on the order of a few hundred meters at least, right? To build entities, some of the boundary layer cloud is all. The problem is that they really miss the whole problem of how cloud get formed. I don't think it's formed by microphysics. It may work for this little patch of region this big, by the way, this camera this big. Small little region, because you can pack a lot of micrometer in this region. But you cannot possibly pack micrometers in the real cloud out there. Because most of the cloud are formed by fluid dynamics, by basically inversion process. I just pointed out that most of the marine low cloud, I would propose, one of the great misunderstanding about this cosmic ray cloud theory idea, is that is how cloud get formed. I would really strongly say that you really need a lot of this, what you call large-scale phenomenon. It's about fluid flow, it's about inversion, it's about downdraft, it's about water vapor availability. By the way, the idea that you have cloud charged particle to enhance the nuclei of some existing nuclei like aerosols particles, the marine boundary is producing enough nuclei. You have more than enough. Okay, but this is part of the real problem, that if you dig very deep, this theory doesn't hold. And they are very, by the way, I'm not underestimating Heinrich Schweinmark. They've been studying this issue carefully also. But unfortunately, there's just a few of those things that they refuse to look at, refuse to think about it. They've been trying to find only evidence that support their ideas, but refuse to look at evidence and don't support their ideas, which is not a good thing, right? You really have to be open-minded in that sense. Although I know he tried very hard, he tried to build experimental tests to show, but most of the experimental tests are not very useful or insightful because it was all testing the microphysics. They are only testing the concept of how the enhanced charge on the electron will enhance nucleation. That one, I think you can show that, which is indeed you need to show that, obviously, but it's well known. Some of my good colleagues, this guy Fan Guan Yu from University of Albany, who used to be a student of Richard Turgot from UCLA, he was among the early proponents. He also realized that by the way, they are trained in meteorology, so they realize also that most of this idea may not work. Simply because cloud doesn't get formed by microphysics. Just imagine things on, by the way, Henry Sommer has gone so far to try to say that in terms of distribution of the particle size, they are really dealing with sub-nanoparticles. These are including people that in forestry. One of the most famous guy in that field is actually Kumala from Finland. They were able to convince the sun to do this experiment, this so-called cloud chamber experiment. It's not real cloud chamber. It's basically ultra clean lab. The aerosol community was completely bought into doing this experiment, which I don't mind actually, but I tell you, it's not towards answering climate physics. It's to understand cloud aerosols. And because the cloud aerosol community never get enough money and momentum to build such a clean lab, so they want to test the different impurity, the chemical, ammonia, what have you, because if you talk about aerosols, it's not just sulfate aerosols. There are ammonia hydrate, this and that. There are a lot of this biological one, and there are up to 50 or 100 types of different types that they want to test all these different in the widest range of environment. I mean, isoprene, it could be considered aerosol. One of those. Those are all the big molecules that emitted by plants, right? That create this blue haze phenomenon. Reagan was heavily criticized when he said that the forest is actually polluting us if you think they're creating ozone. It's true. Blue haze phenomenon is very well known in West Virginia, in southern Australia. Those are from forests, emitting all these particles, doing this sort of thing, right? I mean, I think to think that the cosmic ray are helping that, I don't think so. This is why a lot of this stuff doesn't fit. That's the whole problem. That's why I'm willing to abandon the idea for now. Because most of the evidence being brought forth is very, very weak. Not only that, it's contradictory. Even the most basic argument to support the original notion to go in that direction is all wrong. So you need to look back. No wonder that sometimes all this fist fight about IPCC doesn't include cosmic ray. I wouldn't even use that argument because it's not working for me. It's just not true. IPCC, by the way, has also claimed that they have evaluated the mechanism. They have already included that in the climate model, according to them. They were able to show that this cloud have no effects, okay? Blah, 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 blah. Both sides are wrong. So I come back to something more simple, which is exactly, all the energy is dumped in the form of radiant energy. So you have to consider that. You cannot escape that. It's the season that is doing most of these effects, intermediary. Not only that, the effects that we always wanted to find, the difference between interannual is of the order of only few degree compared to your local regional stuff that is order of 30, 40, right? Depends on what latitude you're on. Simple basic question on equator. The sun crosses the equator twice. What is the most dominant temperature signal in the equator? It's annual, not semi-annual. You're supposed to have double hem, isn't it? So that also tells you intrinsically that just from irradiance is not working. It's actually, you have to couple with how the energy got balanced and adjust itself, that it memorizes the system. That's where the memory of the thing that's able to smooth two hum into one hum, right? The camels, there's different kind of camels. So we have to study this topic carefully. That's where all my energies are into this.